In this video, you're going to continue to look at HTTP requests, we're going to dive into some of the details, and you're also going to be making a new request to a completely different API on your own as the challenge. Now, before we kick things off, I want to talk about the function that I'm passing in as the event listener right here. This was created as a regular function as opposed to an arrow function. There is no reason this needs to be a regular function. I'm going to actually remove the function keyword, add my arrow in, and convert it over to an arrow function. Perfect. So that is unrelated to the topic of this video, but I happened to notice it and I wanted to address it because I know some students are going to ask, why not use an arrow function? Is it not possible? It totally is. And now I'd like to take a more in-depth look at the HTTP request that we already have over here in the browser. Over here, remember, if you're not seeing a request, all you have to do is refresh while the DevTools are open and it should show up. Now, some of this information is stuff that we, the person who sent out the request, set up. I said I want to use the get method. I specified the URL, and we can see this reflected in columns like method, file, and domain. But the first one is something that we never set up. We never set anything equal to 200 OK. So what exactly is the status? Well, every HTTP response comes with a status, also known as a status code. And as we can see here, this is a numeric value that describes exactly how things went. There are a whole bunch of different status codes for various degrees of succeeding or failing. For example, maybe the service failed because you used it incorrectly, or maybe the service failed because they've taken it down for maintenance to upgrade it to a better, more faster operating system, for example. So the status code is our big picture way to figure out if things went good or if things went bad. So we're actually going to want to look at that status code value when we use the response over here. We might not have target.response text if things went poorly. We're only going to actually get a new puzzle if the request succeeded as expected. There are plenty of reasons why things might go wrong, whether it's something wrong with the server, with your request, maybe you lose network connectivity. That means it's not enough to just ask if things are complete. Things might be complete, but a complete failure. We only want to parse response text when the request is complete and it was considered a success. We're going to use the status code value to determine if it was a success or not. Now, we can actually access that value on e.target just like we can access response text. It lives on e.target.status. So right here, we can console.log that, e.target.status. If I go ahead and save the file and switch over to the Hangman game, what are we getting? We are getting that status code we just saw, the number 200, and right after that, we get our parsed data with our new puzzle, advanced placement classes. So all we're going to do is check for a status value of 200 inside of this if condition, along with our current check for ready state. So after the first check, we'll use the logical AND operator, and we'll check if e.target.status equals right here 200. So this is going to make sure that we only use the response text when the request is finished and when it finished successfully. So let's go ahead and remove that. We can save the file, and when things rerun, we can see that we still get our puzzle because the response code was 200, which means that this code actually executed. What would it look like, though, if we were to simulate some sort of error where the request failed? We can simulate a failing request by heading over to the URL where we currently just access the API directly. When I created this API to generate a random puzzle, I gave it an option allowing us to specify how many words we want in the puzzle. So let's say we wanted a simple one with just one word, or maybe we wanted something a bit more complex with a few words. So regardless of what we want, we can configure the API to give it back to us. To do this, we use a query string. So at the end of the URL, we add our question mark, then we add our key equals value pairs. Now we can't use any key. The key that I've set up for this is called word, uppercase C, count. I can set word count equal to something like 2, and this is only ever going to generate puzzles that have 2 words in them. You can refresh for as long as you want, but you're never going to get a puzzle with more or with less words. Now this is great, it could allow us to adjust the difficulty of the game, but if we use an option that doesn't exist, we're actually going to get an error from the server. So all I'm going to do is add another T onto word count, so I'm misspelling the option. And when I try to run it this time around, you can see that the request does indeed come back, but it comes back with a different status code. Here we're getting a 400 bad request. That is because we have misused the API and it does not know what to do with this misspelled option. Now here we are still getting a body value back. We are getting back an error, invalid query parameter used. So this is why we want to make sure that we're not just getting a response, but that we're getting a response that has a status code we expect, a status code for success. In this case, that happens to be a 200. One thing we'll notice is that our code would currently do absolutely nothing for this status code. We only do something when the request is complete and the status is a 200. What if the request is complete, but the status isn't a 200? That means that we did get some sort of unexpected status and we could trigger or raise some sort of error. Right here, we could add an else if. Here we are going to check if e.target.readyState equals the fourth state, which means things are complete. If it does, all we're going to do is console.log an error has taken place. Perfect. So we want to have the check here as well. It's not enough to just use an else because remember, that would run for the other ready state values 1, 2, and 3, where the request hasn't actually finished. Now with this in place, we can test things out. Let's switch back over to the Hangman application and save our app in its current state. Of course, things work well. Let's go ahead and mess up the URL. I'm going to set up a question mark with key equals value. There is no support for anything called key, so the request is going to return that 400 again. And if I go ahead and save the program right here, we can see an error has taken place. That should be N, not and. Excellent. So by adding just a little bit of conditional logic, we can make sure that we only do certain things when things go well, and we do other things when the request seems to fail for some reason. Let's go ahead and remove the invalid key down below. I'm going to remove everything at the end of the URL, and after the question mark, we'll replace it with the valid one we just explored, word count, setting it equal to, and I'll stick to puzzles that have 3 words in them. So if I save the program, we no longer get an error. In this case, we get the puzzle steep canyon walls. Awesome. Now, before we move into the challenge portion of the video, I do want to point you to a couple of very important resources that are going to make understanding status codes and HTTP requests a whole lot easier. The first is a list of all the available status codes. We can find this by going to a website. It is http://statuses.com. When we head over to this URL, we are going to get a list of all the HTTP status codes available to us. Down below, we have ones in the 100 range, the 200 range, 300, 400, and then finally, way at the bottom, we have codes in the 500 range. Each group of codes has a different meaning. So the group in the 500 range talks about various server errors that could have possibly happened. We could have a more generic internal server error. We could say there's something about the service being unavailable. There's a lot of different status codes for us to be a little more specific as to why we're getting a server error. The same thing is true with codes in that 400 range. 400 range is used for errors. Here we got a 400 for our request, and this is a bad request. So we misused the URL, providing a value word count with 2 T's that was not supported by the service. There are a whole bunch of other status codes, the common one 404 for a resource not being found, which you'll see if you try to go to a URL that does not exist. Up above that, we have our status codes in the 300 range. These are for redirection. So think about a service like Bitly, which allows you to create short links that redirect somewhere else. They use the 301 status code to get that done. Up above, we have the success status codes. In this case, we saw 200, meaning that things went well. There are also other popular 200 status codes like 201, meaning that some sort of resource was created based off of your request. And up above that, we have codes in the 100 range, which personally aren't used very often. These are more informational, and you never really see APIs implementing them at all. So when we work with APIs, we're typically going to see things in the 200 range, the 400 range, and then sometimes the 500 range. Pretty rarely are we going to see things in that 300 range, and almost never will you ever see anything in the 100 range. Each status code in this list is actually clickable, so if we scroll down to the 404, we can actually see what it means. We get a little information about what it's likely being used to tell you. In this case, it's telling you that the thing you're looking for does not exist. So this is a really great website when it comes to figuring out exactly which status codes mean what. Now there's one more quick thing I want to take a moment to point out, and to find this resource, what we're going to do is head over to MDN and we're going to search HTTP message. When we head over here, we're going to go to the first page talking about HTTP messages. And the reason I'm bringing you here is to show you exactly what information is getting sent back and forth. What exactly makes up an HTTP request, and at the end of the day, it's just a bunch of text. If we scroll down through this page, we're going to get up to a diagram. I'm looking for this one right here. And this is an exact representation of the HTTP request being made and the response that gets sent back. Now, I want to take a few minutes to analyze this because this is going to make it clearer exactly what's happening. There are 4 parts to both the request and the response. We have our start line highlighted in red. We then have our list of headers. We then have an empty line, and then we have our body. So the start line for the request is where we can see the method. In the case of our code, we are using get. And we can also see the protocol, in this case, HTTP 1.1. Now you'll notice that the start line on the response side of things is a bit different. This does indeed still contain the protocol, but the protocol now comes first. What comes after that is the status code. So the request says what method it wants to use. The response said exactly how things went via the start line. Now, after that, on both sides, we have a list of headers. Headers are just key value pairs. For example, the key here is host, then a colon space, then the value, localhost 8000. For us, this would be the URL that we provided right here. Now, there are a ton of different headers that you can set, and you can also just make up headers. I could have a header called Andrew Mead and give it a value if I wanted to. So when we work with headers, it's typically API specific. If you work with an API, it'll tell you if it needs you to set any headers or not. In most cases, the answer is no. Now, in the example of a response, there are headers that get set as well. One of the headers, server, tells you what type of server you're working with, and another one, content type, tells you what exactly is coming back. Is it HTML? Is it a JavaScript file? Is it XML? Is it JSON? By setting the header, the response can describe to the requester exactly what's coming back in the body. Now, after we have our headers, we have an empty line to separate the headers from the body, and below that we have the body, either the request body or the response body. In this page, they requested an HTML document, and that's exactly what they got back right here. In our example, we requested some JSON, so what comes back in the response body is indeed that string. The string we access via e.target.responseText, it's the string that we parse and actually read the puzzle value off of. And that's it. This is all that makes up HTTP requests, and we're never going to manually create this text, and we're never going to see it in our JavaScript code. All of that is abstracted and done behind the scenes. All we do is play around with a few methods on XML HTTP request. It does all of the heavy lifting for us, making sure to correctly generate the request and correctly parse the response. That's where I'd like to stop for this one. I mentioned there would be a challenge in this video. We're still going to do the challenge. I'm just going to push it back to the next video to prevent this one from getting any longer than it already is. So to quickly recap, in this video, we learned about HTTP status codes, which is a numeric value that describes exactly how things went. The status code gets sent in the response. So when you make a request for some data, you don't send out a status code. When the server sends the data back, it gives you a status code saying that things went well or that things went poorly. Now, we also learned what makes up these requests. As we can see here, it is just a bunch of text. We're never going to work with this text. Instead, we are just going to work with the interface given to us by XML HTTP request. And that is a great transition into the next video, where you're going to be setting up a brand new request for a brand new endpoint, a brand new URL, allowing us to access some new information. I'm super excited to get to that challenge, so let's go ahead and jump right into the next video.